All right, in this second video of lesson 5.3, we're going to look at a couple more examples of when I might need to write a rule or an explicit formula for a geometric sequence given some different pieces of information. So in this first example, we're told that one term of a geometric sequence is a sub 5 equals 54. So that means the fifth term is 54, okay? And the common ratio is 3. Write a rule for the nth term. All right, well, things that we need to know to write a rule for the nth term of a geometric sequence. If you remember from the first video, my nth term is always going to be found by taking the first term, whatever it is, times the common ratio raised to the n minus 1 power. Now, what we know in this case is we know the common ratio is 3, but we don't know the first term. We know the fifth term. So we're going to play a little algebra game called plug stuff in and then solve for what we know now. So I know that the fifth term is 54. So what I'm going to do is I'm going to put a 54 right here as the output of my function. Okay. Now I get 54 by taking the first term, whatever it is, and I don't know what it is yet, so I'll just leave a sub 1 there. Looks like a q, it's an a, trust me. Times the common ratio, which I do know is 3, raised to the n minus 1 power. N is something I know. I know that to get the fifth term, n must have been 5. So I'm going to take a 5 and plug it in for n, because that's what I plugged in and ended up with 54 as a result. From that, boy, it's messy. Here we go. Now, 3 to the 5 minus 1, well, 5 minus 1 is obviously 4, right? So I'll change that to be 3 to the 4th. So I have 3 to the 4th times something, that's what we're trying to find, is that value right there, a sub 1, is equal to 54. Okay? So, doing a little algebra, 3 to the 4th is going to be 81. Type it in if you don't believe that. Times something, a sub 1, equals 54. So now if I want to solve for a sub 1, that first term, what I do is I'm going to then divide. If it's a sub 1 times 81, undo that with division. 54 divided by 81. Both of them have some 9s as common factors, so that's going to simplify down to become 2/3. Okay, 27 goes in this twice and this 3 times. So a sub 1, and again, not sure about that, type it in your calculator, you'll be okay. A sub 1 equals 2/3. Okay. So a sub 1 equals 2/3, that means my first term is 2/3. So now, when I have to write a rule for the nth term, I've got the info that I need. To write a rule for the nth term, I take the first term, which in this case is 2/3, I just figured that out, times the common ratio, which is 3, and that's raised to the n minus 1 power. So there's my rule for the nth term. Okay. Excuse me. Now, in the next example, we're given two terms of a geometric sequence. Okay. The third term, 45, and the fifth term, 405. Find a rule for the nth term. So remember, the things we need to figure this out is we need the first term and the common ratio. And we don't know either one of those things. Oh boy. So there's a couple different ways to go about doing this. One is to use a system of equations, which is a little bit on the complicated side and I think would be a struggle for a lot of you. So I'm going to show you a different way to think about this. And then in class, we can talk about the system of equations method, okay? So here's what I might do to figure this out. I'm going to think to myself, okay, I know I've got this sequence. I'm just going to put some blanks. There's a term, another term, another term, okay. And I think about, well, what are these terms? I know that the third term is 45, okay? And I know that the fifth term is 405. Things I need to figure out. I need to figure out R, the common ratio. Well, R is going to be, like what I multiplied by to go from this term to this term, and what I multiplied by to go from this term to that term. And then a sub 1 is way back here. That's the first term, and I got to figure it out. So if I can figure out what the ratio is, I think I could probably work backwards to find the first term. Okay? I'm going to find the ratio. I'm going to think to myself, well, I went from 45 times something to get this number, times something to get 405. Okay, so I multiplied to get 405. So what I'm going to do is I'm going to take 405 and see, if I divide that by 45, what do I get? Like, what would I have to multiply by to turn 45 into 405? Well, 405 divided by 45, you can do a little bit of work to figure that out. That's going to be 9, okay? So 45 times 9 is going to be 405, okay? So 9 is not my common ratio, though. So here's what I do with this ratio of 9. It's a ratio. 405 divided by 45 is 9. I multiplied by something 2 times. And something times something happened to be the same as multiplying by 9. Now, I multiplied twice, and it turned into 9. What number would I multiply by, 2 different times and have it be a total of multiplying by 9? Well, what I'm going to do is, because there was 2 different spaces here, and I multiplied 2 times, I'm going to take the square root of 9. What's the square root of 9? 3. So 3, let's see, if I think about that, if I multiplied 45 times 3, I'm going to get some number, and then if I multiply that times 3, I'm going to get 405. Or it'd be like taking 45 times 3 times 3, which is 9, to get 405. So that is going to be my common ratio, R. Okay, and again, you could plug in, take 45 times 3 and put a number in there if you like to see what that is, just to make it make sense. In fact, let's just do that. 45 times 3 is going to be 135. Okay, and then 135 times 3 is going to be 405. You can check it out to make sure, but that's what's going to work out here. So now I know my common ratio. But I still need to figure out what is my first term. Well, in this case, go backwards. Okay, remember, I'm multiplying by 3 to get 45, and I multiplied by 3 to get something before that. So go backwards. 45 divided by 3, well, that's going to be 15. And 15 divided by 3, well, that's going to be 5. So a little bit of thought to figure out the ratio, work backwards to find the first term. Now that I've got those things, I could write my rule for my geometric sequence. It's going to be a sub n equals the first term 5 times the common ratio raised to the n minus 1 power. Now again, there's another way to do that using systems of equations, and we can talk about that, but it can be a little bit tricky. I think this is going to make sense for more of you than not. Okay? Let's do one more example like that. So this is actually number 16 from your worksheet, so make sure you're putting it down there. There we're told that the fifth term is negative 3,888, and the second term is negative 18. So again, thinking about it the same way I did with the last one. I'm going to just put out some blanks here. This is my thought process. I know that the second term is negative 18, and I know that the fifth term is negative 3,888. Okay? So remember, it's geometric, so there was repeated multiplication. We multiplied by something, and by something, and by something, and ended up with this negative 3,088 number. Okay? So I'm again going to divide. Figure out what did I have to multiply negative 18 by to come up with negative 3,888. Okay, so I do that, and I believe, and you can check me on this, it's going to be 216. Okay, so with the previous example, we got 9, and then we took the square root of that because we had multiplied by 2 things. Here, I multiplied negative 18 by something times something times something, so 3 common factors. 3 common factors between negative 18 and negative 3,888 means I should take the cube root of this. The cube root of 216 is 6. Then I'll think to myself, does that check out? If I take negative 18 times 6, I get something, times 6, I get something, times 6. Do I get negative 3,888? I bet I do. Okay, so you can check that to make sure of it, but I'm pretty confident that's my common ratio. Now I just got to go backwards to figure out, well, what was the first term? Well, I multiplied by 6 to get negative 18, so take negative 18 divided by 6, that must be negative 3. So there's my first term. And if that's the case, my rule is going to be my first term, negative 3, times my common ratio, 6, we'll put in parentheses this time, raised to the n minus 1 power. There you have it, writing some rules or formulas for geometric sequences given different pieces of information.